The following chemical energetics question is related to the Hess Law. The question states that the first stage in the industrial production of nitric acid from ammonia can be represented by the following equation. So, a reaction is given where NH3 is reacting with O2 and it's producing NO, nitrogen monoxide, and 6 water molecules. And you're given using the following standard enthalpy change of formation data. What is the value of the standard enthalpy change for this reaction? So, you need to find the enthalpy change for this reaction. This needs to be calculated, and the information that's provided to you is you're given the enthalpy of formation of NH3, the enthalpy of formation of NO, that's also given, and the enthalpy of formation of H2O. So what you have, the data that you have with you is this is known, enthalpy of formation of NH3, enthalpy of formation of NO is also known, and enthalpy of formation of H2O is also given. What is not provided is the enthalpy of formation of O2, and remember that when you're dealing with elements in the standard state, the enthalpy of formation is 0 because an element O2 would be formed from O2, so nothing needs to be done. So the enthalpy of formation of O2 is by default known and it's equal to 0. So what you have is you have the enthalpies of formation of all your reactants and the enthalpy of formation of all your products. And the enthalpy of this reaction can be calculated using the formula, which is that the enthalpy of this reaction would be equal to the sum of the enthalpy of formation of products minus the sum of the enthalpy of formation of reactants. So my products in the above case are nitrogen monoxide and H2O. So I need to sum the enthalpies of formation of products and subtract the enthalpy of formation of reactants, and that would be the enthalpy of this particular reaction. So summing the enthalpy of formation of products, first my products are NO and H2O. For NO, the enthalpy of formation that's given is 90.3. So it's 90.3, but I'm going to, there are 4 nitrogen monoxide molecules, so this 90.3 is for 1 mole. So for 4 moles, it's going to be multiplied by 4. So that's one of my products. The other product is H2O, and the enthalpy of formation of H2O gas is given as minus 241.8, but there are 6 water molecules. So I need to multiply this by 6. So the other enthalpy of formation of product is minus 241.8, but that would be multiplied by 6 because I have 6 water molecules. Now I am going to subtract the reactants, the enthalpy of formation of reactants. The first reactant is NH3, and there are 4 NH3 molecules. So NH3 is minus 46.1, but since there are 4, so that's minus 46.1 multiplied by 4. And then I have the other reactant is O2, and remember the enthalpy of formation of O2 is 0. Elements can't be formed from other elements. So the enthalpy of formation of O2 is 0, so that's 0. So that's basically 5 times multiplied by 0, which is going to be 0. So I need to perform this calculation, and performing this calculation on my calculator now, the answer is going to be, and it is minus 905.2 kilojoules per mole. So the enthalpy of our reaction, of this entire reaction, using the formula that product, the enthalpies of formation of product minus the enthalpy of formation of reactant, it comes out to be equal to minus 905.2 kilojoules per mole, which is going to be, so the correct option is going to be option C.